we're going to transition from this to transformations on Monday. So it's going to kind of help you as we make these connections. But the parent function, and we talked about this briefly yesterday, what does the parent function of an absolute value equation look like? It's a V. The equation looks this way, right? And it starts at the origin. And we talked about that slope just being that line, that 1, 1, up 1, over 1. Just the regular line, y equals x, but the negative part is just flipped up. So that's what the parent graph looks like. Now, for part A, it says f of x equals x minus 5. And so it wants to know how it compares. Now, instead of us doing each one of these by hand for right now, I want to show you how you can do this on your calculator first. So if you'll take out your calculator. And we're just going to kind of compare and see what's going on here with the parent graph as opposed to some of these others. All right. As you graph, you may not have ever seen the absolute value. Thank you so very much. I'll drink it anyway. If you go, we're just right now talking about graphing on our calculator, Logan. If you go in y equals, okay, you don't know how to graph absolute value. If you hit the math button and go over 1, see this one up top, this is NUM for number, go over 1 to that and look at the very first one, it should say ABS. That's your absolute value, okay? So that's the one you're going to choose. Some of you have fancy calculators, and when you hit enter on that, it'll actually put the absolute value signs in there for you, and others of you who have calculators like mine, it'll just say ABS parentheses, okay? Either way, this is still the absolute value, and then I'm going to hit the X button, and I'm going to still stay with a standard window, so zoom 6. Now here's my absolute value. Yeah. Yes, and we're going to do each one of those. All right, so I'm going to keep this one on, and I'm going to show you a little trick because on this paper it says describe how it compares to the parent. So here's my parent graph, my absolute value, and what I want to do is I want to compare it to some of these others. So the first was x minus 5. So I'm going to go into y equals. I'm going to go down to this second equation here, okay? And there I'm going to type absolute value of x minus 5. So remember, it's math, right, enter. And I'm going to do x minus 5. Now, just so you can see the difference, you can scroll over. You see this line right here beside y1? You can go over and click on that, and you can change it to a bold line. You can change it to have shading. You know how we shaded above or below? You can choose it to shade that way. You can choose to trace it. That little arrow makes it trace, or that little bubble. That bubble makes it trace but doesn't leave the graph behind it. Or it could be a dashed line because, you know, sometimes we need a dash. I'm just going to make it bold so you can tell the difference. Remember, the new one we're graphing is going to be bold, but they're both going to be on the same graph. Yes. No, I'm going to show you a new way to do it by hand. I'll holler at you when it's time to, when I show the new way. All right, so I'm going to go ahead and graph this as compared. Now look at my new one. Remember, this one is x minus 5, the bold one. So here's x minus 5, and this is just the parent. What has changed? What is different about the bold graph as compared to the original? Over like how many? What do you think? 1, 2, 3, 4, 5. Huh. You think that's a coincidence? Look at the equation. Look at the equation we graphed. Look at what we got. So how is it different? It slid to the right 5. Do you see that? Okay, let's check the next one. The next one's x plus 9. So go into your y equals. Instead of this equation, again, I'm going to make it bold just because I like to be able to tell a difference, but you don't have to do that. If you scroll over to where you're on this side over here and just hit enter, it'll change what the line itself looks like. Now I'm going to do math absolute value of x. I'm going to close that absolute value off, and then I'm going to do plus 9. So that the plus 9 is outside the absolute value. I'm going to graph again. Any guesses as to what might happen before you graph it? Do y'all remember transformations from? I can't see it too much, but I can see it starting here. Where does it look like that vertex is now? At 9. And in fact, let's go ahead and on your paper, this one went right 5, and my new vertex would have been 5, 0. This one, the new vertex, what did you say it looked like it was? At 9. So 0, 9. Everything else looks the same, so I'm going to say it looks like it just went up 9. Oh, sorry. Okay, let's do the next one. Take this one off. Negative absolute value of x. Negative absolute value of x. Again, I'm going to make this one bold. I'm going to graph. What happened? It just went upside down, flipped upside down, right? We call it a reflection over x. So here, how is it different? You can say whatever you want, upside down, reflect over x. It flipped. Where's the vertex? Same place, it didn't move, right? The only thing that happened was that graph just went whoop. You try the next one and see what happens. Graph that next one as compared to the parent. What happened? Looks like two things happened. What two things look like it happened? It looks like it went down some. What else does it look like it did? It got skinnier, right? Do you see that? I think that skinnier might have something to do with this. Just like my quadratics, remember as that number got bigger, my parabola squeezed in more? If you had to guess, based on the ones we've done so far, what do you think that vertex went down to? -2. So my vertex here looks like it's 0, -2. Are you starting to see a little bit of a pattern yet? Okay, do the next one. 1/4. Now remember, if you're any type of fraction, make sure you're in parentheses. So parentheses 1 divided by 4. What'd you find? This one's kind of crazy. Crazy. It's really wide, so I went wide. Again, look at that. Same thing happened when I had a parabola, didn't it? What else? Not just it got wide, but it got wide and then it did what? Slid over, right? Which way did it slide? To the left, so it went left. Where is that new vertex, do you think? It slid left 6. I would say that's a good hypothesis. Do what? It is true. I was just trying to get you to get there. All right, let's do the last one. Tell me before you graph it, before you look at the graph, what do you think is going to happen based on what you've seen in the others? Normal? Does everybody agree with normal width? What else do you think's happened? So you're saying left and what? What else? Reflected. I would agree with reflected. Why did you say reflected? That negative in front. I'm thinking it's going to be upside down. Left, and then what? What's the 2 going to do? Down. You're exactly right. Down. So graph it and see if that's what happens. Did I go left, down, and reflect? We'll go there. What do you think that new vertex is? How many do you think I went left? 7. So -7. What do you think the y part is? Negative. Now, I did all that, and I say all that to try to show you a slightly easier way of graphing absolute values rather than setting the absolute value to 0 and finding the vertex that way. This only works when it's in vertex form, but 99% of the time your absolute values are in vertex form. So what is vertex form? Vertex form of an absolute value looks like this. Looks very similar to another vertex form we learned, right? Remember that quadratic, vertex form of a quadratic? Same thing, same things are going to happen here. My vertex is going to be HK, but notice, remember on this sheet, whenever it was subtracting, it was moving it to the right. When it was adding, it was moving it to the left. So I have to be careful because this H has the opposite sign. Now, the A in front is the slope of the line on the right side. And then negative a is going to be the slope on the left. Or opposite a. Okay. So let's use this. Let's see if this is a little bit easier for us to graph in than the other way was to graph in. So look at number 1 on your sheet. We have f of x equals the absolute value of x minus 2 minus 4. Where is your vertex here? What's your slope on the right side? Because this a is 1 over here, it has a slope of 1 on the right. So I'm just going to go up 1 over 1. Now, I said the slope on the left was the opposite of that, or the negative of that. And the reason for that, remember, is absolute values can't be negative. So we switch everything. Now, if you want to just reflect this point at this time, you can. If you want to come to the other side and go up 1, and then the other way, so you see the negative slope, you can do that. But either way, is that a little bit easier to graph than yesterday? This was slope. The slope was 1 on the right side because of the a. So I just went up 1 over 1 from the vertex. Not in vertex form. Not in vertex form. There will be at some points, but not when I'm in vertex form. It'll be outside the absolute value. Yeah. What is what a bracket? It wasn't. I slipped. Yeah. It's just. I'm sorry. What's the domain here? What's the range? That's right. Logan, this is the only new thing I forgot to tell you that we were doing the news. Okay. I'll just show. We just did the vertex of the vertex and then do the slope. That's the new way to graph. That's it. That's all. Look at number 2. Try number 2 graphing this way. Then we'll do it. Just like vertex form of a quadratic. Then the slope. Yeah. Inequalities do the same thing. You just got shading on there. I'm going to do that. I'll do piecewise and show you. No. She was saying, yes, she got it. It is. No, because we were setting the inequality to 0 and finding the vertex. All right. Did y'all get number 3 or number 2? What's the vertex? Close. -5, 0. Right. Opposite sign. Right. Now I'm going to do the slope on the right. What's the slope? 3 over 1. So I'm going to go up 3, right 1. You can do the same on the left side, but the other way, or you can just reflect it, whichever you'd rather do. I prefer reflecting. Notice how it's skinnier than a regular graph. That's that 3 in front. It is also slid to the left 5.
So there's a number in front of that.
Yes. What's the domain? What's the range? Better? Much better? Yes, okay. Let's flip it over and let's do it piecewise. And let me show you how we're going to do this a little bit differently. This is number 7. Y'all should be getting to be pros at piecewise. Do it like we've been doing. Yep, yes, sir. Bottom up, not left to right. So lowest Y value. 7. All right. The first one is the same way we've been doing. So I'm going to plug in the boundary, right? And I'm going to say, okay, if I plug in -1, what do I get? So I got -1, -2. Is that point open or closed? Why? There you go. That's right. There's no line under it, so it's open. Now, another point. Which x should I pick? -2. If I pick -2 and I plug that in, what do you get? -6. Somebody whispered. -6, right? So -2 -6. Okay, that's old. We've been doing that. Now when we look at the absolute value, the first thing I'm going to do, I'm going to still plug in the bound first. I'm going to find that cutoff point, okay? Because regardless or not, that cutoff point is going to be in there. So let's plug in and see what happens. At -1, what is my Y value? So -3, absolute value, -1 plus 3. Whole thing. I got -1, -6. Is that what you guys got? All right, open or close? Close. Close because of the line under it, right? So -1, -6. Now, before I go any further with this, I'm going to stop and check the vertex. And now that I know how to find the vertex very, very easily, this is easy to find here, right? What is the vertex? -3, 0. Is -3, 0 in this restriction? When I cut it off at -1 and I only go bigger than -1, will the vertex be in the area that I need? No, because -3, 0 is here, right? But I'm cutting it off here. It does, but think about what this would do. If I graph this whole absolute value, it's going to look like this, but then my restriction says, wait, don't let it be any smaller than -1. Make sure once you hit -1, that's where you cut it off. So none of this is on my graph anymore. Do you see what I'm saying? I need to check to see if I need the vertex or not, because it just might be, like in this case, that I don't actually need the vertex. Does that make sense? Is the x part of the vertex greater than or equal to -1? No. We've already grabbed the top one. Okay, so what do you do if it's not? Well, what would happen? Am I on the right side of the vertex or the left side of the vertex? The right. So what's my slope? -3/1, right? So from this point, I'm going to go down 3/1. From the point I plugged in to start with. The slope was -3/1, right? That's that A in front. How I got the second point? Is that what you said? Yes. So before I can get the second point, I have to check the vertex, okay? If you get no for the vertex and you don't need it, then all I have to do is do the slope from that point, from that first point. So I look back at the graph and go, well, wait, the slope was -3, right? So I'm going to go down 3/1. So if I reflected, you're talking about this one? This one? Because if I reflect it, it's going to be, remember, this is my vertex, not this. So if I actually drew the whole absolute value, it would look like this. And that reflected point would be way over here where I'm not supposed to have any of this graph. Yep. If you don't need the vertex, it's an easy problem because you just have to do the slope and go. Fall out of the chair. Dear Lord. All right, let's do. It's because I'm answering questions and fielding things. We're done. Look at number 8. Look at number 8 with that piecewise, and let's look at, no, shading only happens on ones like 9 and 10 when the inequality sign follows the f of x. All right, so I won't do every piece of number 10. I'll just do the absolute value, of number 8. I'll just do the absolute value part, which is the first part. Nine. 8, golly. Okay. Plug in the restriction. Okay. First things first, plug in the restriction. Don't talk to him. All right. First thing I'm going to do is plug in the restriction to the absolute value, right? So I'm going to take that restriction and I'm going to say, okay, what happens if I plug it in? What value do I get? In other words, what's my starting point? What's the point where if I drew that imaginary line and just slice that graph up, what's that point where it hit on the graph? So plug it in. And I get 2 when I do that. Did everyone else get 2? And we all work through absolute values that way. Everybody okay? All right. Plot that point. Should it be open or closed? Closed. All right. Y'all seem to have a handle on that. Now, what is my vertex? I'm going to come over here to the side. What's my vertex on that graph? -1, 5. Look at the x part. Is -1 less than or equal to -4? And that's a big question mark. No. So I don't need the vertex. I don't have to worry about it. Why? Because my vertex, this is my cutoff and I'm going to the left, right? My vertex is all the way over here somewhere, right? So my graph would be doing this. I don't need this because I only want the left side of it. So now I can just apply the slope, but this time I'm going to the left. So I got to do the opposite of the slope, right? What's the slope? -1. So I'm going to make this look like a line with a +1 slope. So down 1 and left 1 instead of right 1. And there's that piece of a graph. Because I needed it to have a positive slope instead of a negative. Because this was the left side of the vertex instead of the right side of the vertex. Better than yesterday, a little bit. Do we feel like we can do them now? Kind of. No? Okay. I'm not going to make you turn this one in. A lot of times I make you do this in class and turn it in before you leave. I'm not going to make you finish this one because I want you to have some time to work on your homework because it is Friday. So what I'd like you to do is, you've got 1 through 16, but 1 through 6 are literally just looking at the problem like we did in class. So 7 through 16 are the graphing. And you got two piecewise? Yeah, 2 piecewise. So it is 10:40. You have 40 minutes. You should be able to knock it out and not have homework. Yeah.